Now the next section is energy and reactions. We need to know something about this energy. All reactions, even those that release energy, require some energy to get started. The starting energy is known as the activation energy. Let's star that as well. It's the energy required to activate it or get it going. Activation energy. So reactions, top of page 3, may either be endothermic. There's that one of those words you've been asking about a lot of these year. Endothermic absorbs energy, surroundings feel cold, or exothermic, which is releases energy where your surroundings feel warm. The energy of a chemical reaction is usually measured in heat. Those are our Q equations. Okay. Our heats of reaction. We've got a lot of different ways we can say heats of reaction. Heat of reaction is also called the change in enthalpy. Enthalpy, or delta H. We will call it delta H. We will call it enthalpy. We will also call it heats of reaction. It'll be used all three ways interchangeably. This is the difference in enthalpy between the products and the reactants. So we've got that delta, so it's going to be heat of your final, which in this case is your product, minus your heat of the reactant. Okay. So, since heat is H is heat content, if delta H is positive, it's endothermic. If delta H is negative, it's exothermic. And no need to memorize this. See table I. I'm going to pull out table I. I'm going to look down at the note. Here's table I. I'm going to go all the way down to the bottom. The delta H values are based on molar quantities represented in the equations. Okay, so that means if we start with one of this, that will be the number we use. Whereas up higher, if we start with 2 carbons and 1 hydrogen, that would be the number we use. And we'll get into that later. It's more the second sentence that I'm looking at. A minus sign indicates an exothermic reaction, which corresponds to what we just wrote down. If delta H is negative, it's exothermic. And then I give you 2 examples of how it can be written. The energy can be written in the equation for both endothermic or exothermic, or it can be written after. So you're going to want to read this. It says endothermic absorption, meaning it's a reactant. Exothermic release, meaning it's being put at the end. Or it can be shown as a number. So an exothermic reaction may be shown 2 ways. We could put a delta H at the end over here. Remember, a minus sign means exothermic reaction. Or we can put a plus sign and put it right in the reaction. If a reaction exothermic in one direction must be endothermic in the other. So I'm going to flip all these equations around, and now it's delta H is written over here. A plus sign means endothermic, or we write it right in the equation. Both ways work. Neither is wrong. You will see it both ways. Okay. One more thing with this. We're going to flip the page one more time. And I'm right at the top of page 4. If twice as much carbon dioxide reacts, twice as much energy is needed. Important for us to know this because it does factor in. So if you look at table I would be half the amount. Everything is halved. But since we doubled the amount, we have to double everything, including the energy.